everyone, and welcome to Elements in the Periodic Table Notes. Now, you might think that all we're going to talk about are elements, but there's a lot of different periodic tables. There's the periodic table of video game characters. We can arrange all of these characters based on characteristics. There's the periodic table of metal, where we have all the different metal bands arranged in a table. We have the periodic table of Final Fantasy characters, where someone took the time to arrange all the Final Fantasy characters into a nice periodic table. Now, what all of these tables have in common is that they all have different things arranged in some kind of order. And the periodic table of elements is no different. It's got a whole bunch of different things arranged in a particular order. And they're arranged this way because they have similar properties and they are all elements. So this is a way for scientists to easily arrange and look at all the elements, what everything is made of at the same time. It's all right there. It's all in the periodic table, and it's just amazing. It is one of the biggest documents of importance within science, and that's why every science room has a periodic table of the elements on the wall, because it's that useful. Now, each one of these elements has some information on it. Each one of these little cells, these squares, has some information on it. One of those pieces of information is the atomic number. Now, the atomic number is also the number of protons. So the number of protons determines what the element is. Helium has 2. If you look on the periodic table, lithium has 3. So this is very useful information because it tells us something about the properties of the element. The atomic mass is what's located as that decimal figure on the periodic table in that cell for the element. And the atomic mass is determined by the number of protons, but also the number of neutrons. And electrons, not so much because they're really tiny compared to the proton and the neutron. So the hydrogen, for instance, exists mainly as just a proton and electrons spinning around. So it has an atomic mass of close to 1. Occasionally you'll find hydrogens with a neutron, and sometimes 2 neutrons. These are different isotopes. So they're the same element. They're still hydrogen, but they have slightly more mass, and they're called isotopes. Now, that atomic mass is usually given then as a decimal. But if we want to find out how many neutrons an element has, all we have to do is take our atomic mass and subtract the atomic number from it and round it, and that'll give us how many neutrons is most common for that element. An ion's a little bit different. So an ion is when you have a different number of electrons. Protons are kind of stuck in the nucleus, so they don't travel at all, right? And it's a good thing they didn't, because if they move, then you change what the element is. But you can gain or lose electrons on an element, and that'll create an ion. So if you gain an electron, you gain a negative charge, you can become a negative ion. If you lose an electron, you then have more protons than electrons, you would have a positive ion. If you have the same number of positives and negatives, they cancel each other out, and you get a neutral, or what would have a 0 charge. So that is what an ion is. Now, the next thing to know about the periodic table is the table itself as a whole. So we learned about the parts of what each one of these is. Now let's look at the whole thing. So each one of these different colored sections has a name. And they're named different things because they have different general properties. For instance, the alkali metals, which are in that first column, the first family, those all have high reactivity. They don't exist by themselves in nature. They're always reacting, right? And they're metals, so they have properties of metals. We have very reactive nonmetals that are in group 17. So if you look at group 17, the halogens are extremely reactive, and they don't exist by themselves in nature either. So those are properties of those families. The noble gases at the far right, they don't react at all. They're very happy just the way they are, so they don't gain or lose electrons. They're just kind of, whoop, I'm happy. I'm not going to react with anything. Thank you very much. We also have different rows, right? Like the lanthanides and actinides, which actually kind of get pulled out, because otherwise the periodic table would be very long, right? Those are often radioactive, so they're dangerous, and many actually have to be made in a lab. They don't occur naturally at all. So each of these have a different section, but the main thing we want to look at now is that the majority of the periodic table is metals, with a few nonmetals in the top right corner, all right, but mainly the rest of the periodic table, metals. All right, now metals have certain properties. They're shiny, they have luster, they're malleable, they can be made into sheets, they're ductile, you can make wires out of them, and they're good heat and electrical conductors. So those are properties of metals. Nonmetals are kind of the opposite of metals. They're brittle, they just kind of break, you can't bend them or make wires out of them. They're not shiny, so they're not good conductors of heat or electricity, usually. There are some exceptions. So most of metals are also solids at room temperature, except for a few, like mercury is a liquid metal at room temperature, whereas nonmetals can be solid, liquids, or gases. Metalloids have properties that are kind of like metals, they're kind of like nonmetals. Little of both. Silicon is a great example. It's a semi-conductor. It kind of conducts electricity, but it kind of doesn't, which makes it useful for electronics. So the silicon wafers are what's used in your computers and your phones and everything for all those circuitries. Okay, so this is a section that is described generally as a stair within the periodic table. So we look back at this periodic table. Here they're yellow, right? These are the metalloids, right? Also, if you look to the left of it, all metals. To the right, the nonmetals. So that's kind of a transition zone. So this was all about the periodic table. And there are so many different types of periodic tables we can look at. And even within the periodic table of the elements, there's all different kinds. But let's get to know the parts. Let's get to know what all the little parts of each element mean and understand the world around us.